first. Then we're going to dive deep into it.
Okay,
All
I'll
right.
hold the rest of my questions until.
All right. Okay, now we need to make room. We're going to talk about the site itself. There's been a lot of questions on the specific site. So we need to make room up here for both Mr. Cundiff and Tim T. So if maybe, okay, and then you'll be back. And make sure Mark Davis has a microphone close to him. And while we're doing this, Roger, did I neglect to introduce you? I know I said you were the rep for the K through 8, but I don't think I said much about you with all your background. Okay, so I want to do that now. That was a big oversight. Okay, no, it's not. Roger Talon, who's done everything in this town, select board, selectman, advisory, K through 8, anything called upon. So I'm very sorry. I was sitting here going, I don't remember introducing Roger. And okay, so I figured you'd take it out on me later, so I thought I better correct that. Okay, so now we have invited Bill Cundiff, our DPW superintendent, whose feats for the past year we lauded a few minutes ago, and Tim Teese, our longtime water consultant, for lack of a better word, from PAR. P-A-R-E should be PAR, just so you know. Okay, so PAR, even though it's spelled P-A-R-E. Okay, so what we want to do with this segment is talk about the landfill, explain where the landfill is, what you know about the landfill, what we've done to investigate the landfill as this process has gone on, and what other steps are going to be taken to make sure that we continue to provide a safe area for this school to be built on.
Sure. So I can provide a little bit of background on the landfill. So the landfill, we refer to it as the Parkerville landfill. You may also hear it referred to as one landfill.
Hold on a second. I'm not sure we can.
Can you hear me now? Oh,
Yeah.
Sounds like it's on. So the landfill started. It was used as a going back all the 1930s. Some of the reports I read suggested that the landfill was actually used to bury debris from the 1938 hurricane.
I still think you got a problem. There you go.
Hold it down. Oh, can you hear me now? All right. So what I was saying is that the landfill goes back possibly as old as 1930, 1938, right? There's records that say that building debris was buried there after the hurricane in 1938. But it wasn't really used as a landfill proper until the 1950s. It was what's called an open burning dump. People would dump their trash there, and it was quite literally, it was just burned in the open. It was converted into a solid waste landfill and a formal landfill in the mid-1950s. In the mid-1950s, and it was run as a landfill until the mid-1970s. Okay, it was capped and closed per state requirements in the 1990s. Around 1995 is when that process started. The landfill itself, like I said, you might refer to it as Lundblad Field. It is the field up against Parkerville Road that has the junior soccer area on top of it. That is more or less the entirety of the landfill. It does wrap around a little bit to the south, but it's that mound right up against Parkerville Road. And it's about, at its closest point, it's about 300 feet, 400 feet from the Neary school. So since the landfill was capped in the 1990s, the town has set out to do what's required per the state and per the EPA, which is to monitor the landfill in perpetuity. And so the town monitors the landfill on an annual basis for groundwater and surface water impacts. Essentially, samples are collected from groundwater, samples are collected from the surface water, and they're analyzed for a whole number of constituents. That's done on an annual basis. On a quarterly basis, the perimeter of the landfill is monitored for what we call landfill gas. Now, landfill gas it's a number of different gases combined. It's methane, hydrogen sulfide, carbon monoxide, and volatile organics. And that monitoring happens, like I said, on a quarterly basis. So the landfill right now is ringed by landfill gas monitoring points, as well as landfill gas vents. There are also groundwater monitoring wells, both shallow and deep met wells around the landfill, right? And like I said, those are monitored on an annual basis. So my firm, PAR, we've been involved in this with this landfill now for about 5 years, doing the groundwater monitoring. Like I said, we do it on an annual basis. We collect samples, we send them to a lab, and the list of things that they're analyzed for, it's literally hundreds of potential pollutants. And we find consistently about a half a dozen pollutants in the groundwater, but at relatively low concentrations, right? The things that come up the highest beneath the landfill are iron, manganese, and sodium, okay? Those are, iron and manganese are not particularly toxic. Sodium is not a toxic contaminant. It does have health impacts if you consume too much of it. And then we do find very low concentrations of some other contaminants like arsenic and 1 or 2 volatile organics. But the concentrations that we typically find in groundwater around the landfill are very, very low, right? On a quarterly basis, like I said, we do monitoring of the landfill gas. And much like the groundwater and surface water, the landfill gas that we find is very, very low. Most quarters that we do it, it's actually non-detect, meaning we don't actually detect anything in the soil probes that we have in the ground around the landfill. So, you know, I'm happy to say that the landfill right now, it appears to be very stable. It does, you know, landfills do decompose over time. This one appears to be fairly stable. And we're not seeing significant environmental impacts much beyond the landfill to surface water, groundwater, or the air around the landfill. So that's a very short overview of essentially what we do on an annual basis out there. I suppose I'll open up to questions if that's okay.
So can you explain how the school got built there, given there was a landfill right there? What was the, and if you don't know, Mark Davis probably can. So it might be a good chance for you to kind of chime in as far as how we have a landfill where we have a school already.
So I'm not, that's a good question. I don't actually have an answer for you. I don't know why the school was put where it is today. I do know that we have records of the school existing around the time that the landfill was active, or right around the time it was starting to close. But why that was selected as a site, that I don't know.
Mark, you want to chime in here?
Yes. Do I have to hold it?
No.
How about now? Ah. My understanding is the site entirely was donated to the town. So there was a large enough parcel that you could put a school on at the time. And that's about as far as I know as to why there's a school there. Thinking back to the town I grew up in, schools were relatively close to landfills in that town too. I don't think we thought much of it in the 60s. But I don't think that's the best explanation, but I'll get into it a little bit more.
That's okay. Okay, so Tim, back to you. Can you explain what other steps are going to be taken as far as the school project? And I think, Jason, we probably ought to explain the site itself. So the original site that we had first looked at was actually not where the current building is. It was where, if you remember when we had the last 2 town meetings outside, it was there. So we were going to keep the school in place, build there, and then close the school and move over. But there was extensive testing of the soil there, and the soil was not good. We were going to have to literally go in and remove 6 feet or so of all that soil, truck it out, and bring in new soil. So it was going to be quite a process to do that. So therefore, we did start looking at some other sites. The school group wanted to try to maintain the campus feel of the 2 schools, Trotter and this one. So we did look at a couple sites surrounding there, didn't spend a whole lot of time with that, and then decided that the best place to then look as the second choice is where the current school sits. So that's where we ended up with, is that site, tearing the current building down and putting the new school pretty much where the current school sits. So Jason, with that, add anything you want to, but
Just one point on the fill, it was, in the design team will keep us honest, it was because it was not structural fill, so it was not stable enough to be built upon. It wasn't the soil itself, just to make sure everyone's working with the same information. I would like the design team, unless Tim is better suited to do this, to walk through the mitigation measures that we've built into the design, in addition to what's already been documented of what's already ongoing, because I think there was some suggestions made that we've built into the design as well.
Okay, we're still on. Yes. So as Kathy was mentioning, we did, I believe, 6 borings in the 4 borings. Okay, 4 borings in the area just to the north of the school, which is planned right on this drawing, which is just behind you guys, in the area of the existing athletic fields as the sort of primary site. And what we discovered or concluded is that much of that land was filled with what's known as common fill to create those fields. So the land was much lower, and as we said, was about 6 feet of fill that was placed on top of that. So it was soil that was trucked in, placed there to create the tabletop for the fields, and would have to be either scooped out and carted away, or other techniques used to make that possible for the bearing of a school. That was, if I remember correctly, about $2 million worth of work just to clean that soil out and put in new soil to bear the building on. And in a series of investigations, analysis, we looked at and felt like if we can take down the existing school and put the new school there, we have more stable soil to build on. Likely there will be some still amounts of fill around the edges of that building as we go forward. Talking to the work that we're doing on the school itself, we are trying to pull together several ideas about the way to protect potential vapor that may show up in the ground from the building. So what we're talking about is putting in a vapor remediation system. Some of you may know it as sort of like a radon system. There's pipes in the ground. You pull the air out through the building or through a series of vertical pipes and release the gas to the atmosphere, as well as then a vapor barrier underneath the slab. So those are steps we are investigating in order to prevent, in the event that any gases or chemicals are moving through. Although, as you can see from this diagram, the 2 monitoring wells, there's a pair of monitoring wells on either side, are showing, to your point, minimal intrusion of chemicals from the landfill.
okay. Mark, do you want to add to this discussion?
Sure. One of the main reasons I got on the committee to begin with was I was concerned about the location of the school near the landfill. And I think the committee will kind of smile a little bit. I've probably been the loudest one on the committee about asking questions about it, as well as asking questions about the wetlands and the existing river, which is that blue line to the right, and where we can position the school to best ameliorate the conditions that we're dealing with. I look at the Neary School as the bottom of a bowl. If you drive in, you're driving to the bottom of the bowl, and everything kind of sits there with the school, the fields, and the parking lot. And if you were there in the last couple of weeks, there's even a standing puddle right at the foot of the hill, right in front of the existing soccer field that just doesn't want to go away. That's kind of the low point of the entire site. So we needed to understand what's going on with the landfill. How does that affect the site? We need to know what's going on the surface But we also have to fully understand what's going on below the surface, because that's where all the trouble reigns. And that's what we really need to understand. As I understand the groundwater in this area, and I did attend the town meeting in the 90s with the capping and recall that question being asked at town meeting. Where's the groundwater go? It flows north and slightly west. And if you know the area well, if you drive down Parkerville toward town, behind all those houses is a large wetland area, and you can see Trotter off in the distance on the uplands. That's kind of where everything goes on the surface. That river I pointed out flows into that area. All the wetlands drain on the surface to that area. And it doesn't always work this way, but the groundwater is flowing in that direction as well. If you flip it back to the other slide. So we know where the water's going on the surface. We know where it's going underneath. Of the two monitoring wells, you have one that's closest to the school. From the school's perspective, that's the well, as a town, we need to be concerned with. That's going to be our first alarm that there's a problem. And in the 30 some odd years we've been testing this, there isn't a problem. There's low stuff that the engineer talked about there, but there's nothing that's overly concerning, and it hasn't been increasing. So the models that were done in the 90s seem to be testing out. And those two wells are very critical to Neary. When we originally looked at it, we also, as just was said, did some soil borings. We needed to know what the soil conditions are. And one of the borings that we recently did was between the school and that monitoring well, not far from where that puddle was that I talked about. And we found all sorts of debris, wood, rotting wood, typical debris that you'd see in filled wetlands. So we're not going to be building there. We want to stay as far away from that as possible, because you can't build on that type of soil. And that's why we did move the school back to where the existing school is. Is there some risk of putting a school where the current one is? We don't truly know what the soils are underneath. We'll be doing further testing there to make sure the foundations will be proper. But in the studies that we've done so far, we haven't seen anything coming up through the foundation. We haven't seen the typical things you'd look for to determine whether there are structural issues. So the one boring that we did right close to the school, it was consistent of sandy type soils. So we may have dodged a bullet. The recommendations that the engineer pointed out are, I've been strongly urging, which is to pull the water out from underneath the school. We are also in a high groundwater area. We discovered during the borings that in some cases the groundwater is 18 inches below the surface, 2 feet below the surface. And just to the south of that one monitoring well that's close to the school, the groundwater is present. It's there, right up near the surface. We've also looked at the 100-year floodplain maps to determine and make sure, because we've had 100-year storms twice in the last 5 or 6 years, to make sure that there isn't a flooding issue. And we're outside the limits of those, what the maps indicate would be the 100-year flooding.
So Mark, are you satisfied with the current steps that are taken to monitor the landfill and the additional plans we have for putting the vapor barrier in, et cetera, with the new project?
With one additional thing, I would recommend at the end of the construction that we install 3 more wells right up close to the school. And then we do annual testing on those wells and compare those results with PAR's results around the landfill so that we always are doing a comparison as to what's going on.
Okay, so with those 3, you're satisfied?
With those 3,
Okay, so I want
I'm
Bill,
satisfied.
I want Bill to have a chance to kind of conclude this piece of it with what you think, what we've done, and you believe we're doing the right thing, we're on the right path.
Thank you. So I've been working on this with Mark Davis for a while now and with Tim. The few things, I just want to break it down in very simple terms. There's 2 things that you're concerned about with any landfill. Number 1 is gas, the other is water, groundwater. With this particular site, as I look at it, and if you look at the image on the screen, you'll see just to, I guess that's east, this is a rotated map, there is a water body, or what appears to be an old water body. And as Mark Davis pointed out, that monitor well shows groundwater right at the surface. That water level forms a natural gas barrier. So the chances of gas migration from that landfill toward that direction is minimal. So that's number 1 with regard to the gas. If you add on the active gas extraction system that the architect mentioned, I think that's just adding, minimizing your risk. It's layers of risk and then mitigating that risk. So I think the gas issue is addressed pretty fairly. With regard to the groundwater, the school is served by the MWRA water system, the town water system. We all drink from it. It is a direct connection. Let's assume there is an issue and, based on past evidence, there are minor levels of contaminants in the groundwater. That's not surprising or uncommon for a landfill site. So we look at mitigation and risk. Is there a risk to that? There shouldn't be anybody in that building that's drinking the groundwater or has access to the groundwater. That water supply comes in through the piped in water, MWRA water system. There should not be an issue with groundwater. So between those 2 things, I'm satisfied that the site is not going to have an issue. That's assuming they don't dig up something during excavation. But outside of that, my assessment of what we see, the 2 issues of concern are addressed.
Thank you. Jason, you want to add anything before we do questions? Okay, so let's start with Select Board this time. Al?
Thank you. This has been very instructive. A couple of quick questions. We don't know, so I get the gas bit, that we were talking about sort of the groundwater contamination. We don't know the extent of that contamination. Is that correct? Yeah.
So in terms of the extent, how far it extends beyond the landfill, that has not been mapped. But what I can say is we put these wells, when I say we, I mean engineers in general, we put them around the perimeter of the landfill to intercept, if there's a contaminant plume, intercept it close to the source where the concentrations are going to be the highest. As it moves away from the landfill in any direction, it's going to dissipate. And so that's why the wells are where they are. But beyond those wells, it has not really been mapped beyond that.
So the other sort of, it's tangential, but fairly close to that monitoring well, we actually have sports fields. And, there, on a damp day, contact with questionable water is something that is a risk. And I think we ought to be giving serious thought as to whether that's an appropriate place to have a sports field.
Well, again, what I can say is the contaminants that are present, if they are somehow getting out of the groundwater into the surface water where the kids are playing, they are very, very low in terms of what we have found so far.
That's not something I want to tell a parent of a 5-year-old.
No, I understand. When I say low, in some cases, they're present, but below even what would be considered a safe drinking water standard.
Okay, all right. Those are the questions I have. I'm encouraged that you want to place a set of perimeter wells closer to the schools so that you can make sure that there's a tripwire.
Okay. Marguerite? Side questions?
Just a quick question. The vapor barrier on the school, does that have a lifespan? Do they fail after a certain amount of time?
I'm not aware of failure, but I'm certainly willing to look it up and see. It's usually underneath a slab, so it's not like it's wearing, it's not like it's getting hit with sunlight or something that would tend to erode it, but I can't say for certain, and I'm certainly willing to get back to you on that one.
Is that it, Marguerite? Sam?
Yeah, I had a number of questions, but if Mark is satisfied, I'm satisfied. So, thank you.
High hurdle. Andrew?
I don't have any questions. Thanks.
Okay, so now we'll turn to advisory. So Marcy?
Is the current school on a slab, or is there any infiltration of groundwater now?
The current is on a slab, so it's a slab on grade construction. We have not heard of any infiltration at this point. I don't think anyone has reported it to the school. We didn't see any indications of movement in the slab or in the structure in ways that would suggest there's groundwater impacting the foundation system of the building.
So the superintendent's office is in that building. They're all shaking no. So I think the answer is no. Marcy?
Just wondering if this similar design for the new school would be, also on a slab, and therefore support your claim that no groundwater would be impacting the new school.
Yeah, we are not planning any sort of basement type space. There will be utilities underneath the building as usual, but all that's filled in and sealed off. And looking at some sort of vapor barrier system right underneath the slab, we believe will help to mitigate that.
Is that it?
I'm good. I understand, the barrier. I understand the risks, and I think they're minor as well. But I don't think we're the final people you have to convince. It's the town. So what's the alternative? And is there an alternative? Is it this or nothing? That's what I think you need to be prepared coming to town meeting with. I'm satisfied personally. I understand groundwater. I understand the barriers. I understand the monitoring. I understand the low risk, but I'm one person.
So Jason and I should answer this one to make this clear for now. The project that's in front of the MSBA is a project. If this project is not approved, there can be no amendment at town meeting saying we'll move it someplace. Medfield tried to do that and it's not possible. So the plan is for the building to be at the current Neary site, and that is our project. And if that is not approved, then we kind of start all over.
If we want state funding, we
Right.
can start over as a town at any point we want, if we want to pay for 100% of this through our tax bills, whatever project we decide to do.
And again, this doesn't offend me at all.
Yeah. And we will be ready to speak to at least the town-owned parcels we looked at. That was part of our process, including the existing school sites. So we will have a plan to articulate that.
Thank you.
It was noted that this landfill was capped 30 years ago. Are there any data about how landfills behave over longer periods of time? Landfills like these behave, 40 years, 50 years, 60 years. Do they stay stable? Do they tend to leach more material? Do they off-gas more? Do they off-gas less? I mean, I don't know. Is there any data available that might tell us where this is going to go?
That's a great question. Because we only started capping landfills this way in the 70s and the 80s. That's really when the regulations came around to cap these the way we do today. So this landfill was capped about 30 years ago, which is about the average age of most of these landfills that have been capped, believe it or not, right? So there isn't a lot of data for this kind of landfill with this kind of cap that goes beyond, 25, 30 years, just because they don't exist. But generally what happens over time is with these landfills is that the decomposition slows over time. And it's the decomposition which creates a lot of that off-gassing, the methane that we're worried about. A lot of the shifting of the landfill, which can change impacts to groundwater. That happens because of the decomposition that's going on in these landfills. And like I said, over time, that decomposition slows down. And so that's probably the best I can say in terms of long-term trends for these landfills.
Thanks.
Yep.
Can I just add to that? So we have a contract with PAR. They do our inspections, periodic inspections. Is it annual inspections? And we get a report from PAR, and often we'll have maintenance requirements. So, Tim will share his comments to us. We'll go out and address the comments. I think anybody that's been up to Lundblatt Field will have noticed a settled area in the northeast corner of the field that ponded water. We went out and we graded it and we reseeded it and leveled it off so that water shed properly. We have to maintain these things and we keep on it as we do annually. So, the DEP, actually, we have a great relationship with the DEP on the landfill too. Since I've been here for the past year and a half, I've spoken to the DEP probably a half a dozen times about this site.
One other question, probably for Larry. In terms of the old construction of the school and the new construction of the school, just in case this question comes up, obviously we're going from a 1-story to a 2-story, but the materials are a little bit, hopefully, lighter. Is the load on that site roughly similar as opposed to, like, if it's stable today on the existing slab and on the existing soil conditions, do we expect that a new school would be much more weight that needs to be bared by that site? Or
Interesting question. So let's see, unravel that a bit for you. The existing building is a lot of concrete block masonry walls that are typically these days done with metal studs and drywall. So the sort of inherent sort of dead weight of the building is much less than a typical story would be much less today than it was then. 2 stories a little different, but the weight is coming down through columns rather than along spread footing, so it bears the weight a little different. The live load is a different thing because now we have to take more into account seismic shifting potentially of the building, and so there's more live load that's put into the ground to there's shear walls and things that keep the building from racking during a seismic event. So a little hard to say precisely. I'm happy to get our engineers to give you a little better input if that's helpful. But I think in general, it's probably
it's replacing a giant concrete block basically with something that's a little bit better engineered in terms of
yes.
Weight should be roughly similar, just in case people ask. It's a 2-story. It holds a 1-story. Now we're going to 2. Is it going to be able to hold that? Well, it's a different construction type, and engineers are confident if we had some kind of thing like that, would be good.
Yes.
Tim or Adam? No questions? Okay, so that should be it for part 2, I think, as far as site stuff goes. Okay, so now you probably maybe switch again. We're going to bring our administrative team back up because we're going to talk about the educational benefits and the reason that the project's been proposed, we believe, is the better educational outcome of all the 13 choices we looked at. You can, you can stay if you want to. And we're still gonna do capital, which you're a big part of. So it's totally, I know it's gonna be a late night and I know you got a long drive. You can go on, if you want to go and then jump on Zoom, it's fine too, Bill. Whatever you want to do. Okay, where is Mr. Martineau?
Yes, so thank you for the opportunity to talk about the educational benefits of the proposed building. I do want to begin by talking about process. It's really important to talk about the feasibility phase. The